SPMTs, if you look at the latest drawing, the approved latest drawing 2017, right here, Denny Pate, you can clearly see that those SPMTs were at their location as designed to be, roughly. I don't know exactly, but this appears to be roughly where they were when we saw them transporting. And this is the erection of main span, and you clearly see that these are the transporters. It says typical, meaning it could do something a little different. Nevertheless, we see now that yes, this is not without fault being pointed towards NTSB and FDOT releasing the plans, showing that this was the 2016 plans, clearly sending everybody in the frenzy in the wrong location. With this overhang, because clearly these were designed to be, well, the plans approved plans show it to be here typically. So this was addressed then. It wasn't a last minute decision. This decision was clearly before these plans were stamped in 2017. So again, we have the NTSB and also the Florida Department of Transportation releasing the wrong plans in 2016, purposely causing all this drama with the internet, with the cantilever, and these were in the wrong place, etc. So here we have it. Install bearing pads at Piers 1, and well, you know, this is a detail there. So let me show you guys this. So bring this to your attention. This is the 2017 stamped plans, Denny Pate. Denny Pate. Stage 2 superstructure precasting. Stage 2. This is the failing structure. Cast main span superstructure as follows. This is the main span superstructure. The entire section is considered the superstructure. A. Cast deck and diaphragms. This is A. That's the deck. B. Cast diagonals and vertical members. Install post-tension bars as shown in sheet B38, which we don't have. That would mean these are diagonals and vertical members. They're considering these vertical. Vertical. These are all the diagonal members. You might consider this a vertical member also. You might consider it. Cast canopy and top anchor blocks. So anchor blocks would be bar blisters. So they wanted, this is how it's supposed to have been done. 3 stages. They did a lot more than 3 stages, and I'm really confused by the images they're putting out there, MCM. But okay. After concrete compression strength has reached 6,000 psi, stress post-tensioning of the main span in the following sequence. This is the main span, not the deck, but the main span is everything. Okay, 1. Stress deck longitudinal tendons D1. Okay, down here, this is the deck. Stress canopy longitudinal tendons C2. So that would be C2 in the canopy. 3. Stress post-tension bars and diagonals 2 and 11. Very important. So next, they want 2 and 11 done. As I've always said, I think this might be some type of shearing, a shearing system to keep the wall, the system from racking. So there we go for 2 and 11, sort of reinforcing my idea that these were just shear braces, shear walls as I call them, and really inflamed a few people on that. Shear bracing, shear wall system. Okay. 4. Stress deck longitudinal tendons in the following sequence. So now we're back down the deck. You're going to do D2, D3, D4, D5, and D6. Okay, 5. Stress bottom slab transverse post-tension alternating end stressing is required for the transverse tendons. So you're going to go down here and stress all of these across, all these cross members. Okay, next step, 6. Stress post-tension bars and diagonals members 3 and 10. So here's 3 and 10. So post-tension of bars in there, and 3 and 10. Now we have 5 and 8 coming up next. And as you can see, it's working its way from the outside towards the inside in this whole post-tensioning scheme. All right. Next step. Stress post-tension bars in diagonals 6 and 7. So we go here 6 and 7, which would be probably the middle thinking of it. Stabilizing this, so you're going to do 6 and 7. Next step, stress canopy, longitudinal tendons C3. Next step in the phases, temporary support of main span section shall stay in the middle of the cross section during SMPT transportation. Okay, temporary supports of the main span section shall stay in the middle. So temporary supports, we're supposed to stay in, per these, in the middle of the section during SMPT. So what is the middle of the section? I would say it would be the entire middle section. Interesting enough. But as we all know, this bridge did not have the supports inside of it. No bracing was left. None of the middle of the cross section during SMPT transportation, none of the temporary supports were left when they transport it. In fact, Morales makes a point in one of his letters documenting, one of his letters or emails documenting that he observed the cracks after the forms were removed. But yet, Morales, reading these plans, should clearly say the form should not be removed while they're placing the bridge into position. So there's some serious iffy stuff going on here. You know, why did they do this? Why did they deviate from their own plans? Appears someone had some doubt in their own process. My thinking out loud. Let's talk about this in this capacity. If this was making the bridge stable during transportation and location of placing the span on the permanent piers on each end, let's just call them piers at this point, at each end, it made it stable. What would the effect of detensioning do? It would make it, it would destabilize it if you were taking tension off. So I know in my other video, one of my videos I speak of detensioning could cause the failure. Why would you detension it? You know, I don't have a reason why unless you loaded this to have a cantilevering counter effect when you had your transporter, your SMPT right here, and roughly here, that you use this to counteract it, and then you were detensioning. But by then the break could have already happened, and detensioning now creates a break here. For this one, a break here and nothing here, perhaps no harm done there, but perhaps a break was here. And when you did your transporting, the break identified itself, or maybe the break was there presently beforehand. Detensioning then causes the bridge to just collapse. You know, simple as that. So I want to show you a term that I keep in my mind all the time, as you read it right here in the italics. I mean, in the green highlight, blue highlight. This helps me always make sure or filter myself to make sure that look for something else, to not always associate one with the other. In other words, just because the contractor was post-tensioning, does it mean he's at fault, the post-tensioning person is the cause of the bridge failure? Or is it another event that this contractor, the post-tensioning guy, VSL, happened to be putting his last person a touch and performing his job? Next thing you know, the bridge collapsed. But really, the result wasn't him doing it, but it was a result of him detensioning, what he's supposed to do, but a crack was already present. Also, were all the other events such as not leaving the forms in, what implication or what consequences did that have by removing the forms and transporting the bridge without that extra stability, if you will? It was clearly a very clear thought on Denny Pate's part. And did they change their mind, and did they do the extra tensioning of 2 and 11 that caused a further problem? Keep in mind, the contrary part of this is that his intentions were always to detension 2 and 11. So that was to happen at the end, though, not currently when they were doing it. So could they have been taking some of the extra, quote, extra detensioning off to bring it back down to where they wanted it because they did not use the formwork? Or are we simply just missing plans that have been stamped and they're not sharing it, and we're just in this rat race or a circle chasing our tail? Just some thoughts. Take care. Thanks a lot, guys, for watching and commenting and thumbs up and all that great stuff. And thanks for subscribing also. Thanks.